So the last thing that we're going to test to figure out how healthy this section of 9 Mile Creek in Edina is testing water quality. So this is where we test the different chemicals that are in the creek, and by chemicals I don't mean like pollution or anything like that. I just mean, well, what we're going to test today is phosphate and dissolved oxygen. And you might guess the reason that we want to know how much oxygen is in the creek is how all of the creatures live. So those ones, the damselflies and the crane fly larvae that we looked at earlier, they need oxygen because they live in the creek water. And so we want to figure out how much oxygen is actually in the creek. Now, phosphate is an interesting one to test because it's something that all plants need to live. But if you get too much phosphate, that's how you start to get those big algae blooms. And we want to know how much phosphate is running through our creek system. Now, every part of the creek is a little bit different based on its watershed or the land area that drains to 9 Mile Creek. So, based on the buildings and the highways, 62 that's going by us here, all impact the amounts of these things that we're testing. Now, again, lots of different things impact this. So if we had any rain recently, it might have washed more things into the creek that are getting flushed down. If there are a bunch of rapids or logs in the creek, that will add more oxygen. And so all of these things can impact what we do. So we're going to use these two tests here to judge the color of these two things. So I've taken samples of the creek water and I've put in little testing tabs that will change the color of the water based on how much of each nutrient or oxygen is in there. But we've got to wait for the tabs to dissolve and we've got to wait for them to change color. So I'll see you back in a little bit. So we're testing phosphate here, and now our tabs are dissolved and it's changed color. So we're ready to figure out how much phosphorus is in the creek, or excuse me, how much phosphate is in the creek. Now we measure this in very, very tiny amounts called parts per million. So imagine that we had 1 million parts of water, and out of those million, 4, 2, or maybe even 1 of those parts would be phosphate. So the very, very, very small amounts. So if we look at our color here, we're trying to determine which shade of blue this is. Now it's kind of hard to tell the difference between 1 and 2, that makes sense. But in looking at this, I'm going to go with 2 parts per million of phosphate, just based on how dark this is right now. It's kind of in the middle of the road, not too bad, not, terrible in terms of how much phosphate is in the creek. So overall, I think that's pretty good. Now we're going to look at oxygen, or dissolved oxygen. So we have our second test tube here, and this one has also had a chance to dissolve. Now, we do want to look at the color, but we also, for dissolved oxygen, need to look at the temperature. And I've been having a sample of creek water with a thermometer in it to get the temperature here. So, in terms of how dark this red color is in our tube, I would say it looks closest to 4 parts per million. So, again, that's right in the middle of our scoring, probably a good amount of oxygen for our creatures to handle. And if I look at our thermometer here, taking the temperature, it's at about 60 degrees Fahrenheit, which is kind of warm, and 15 degrees Celsius. And you'll see here on our chart, we need to look in Celsius. So I'm going to go with 14 right here in between at 4 parts per million. If we go over here, we've got about 39% dissolved oxygen. Now, again, this has been sitting for a little while and it might have lost some oxygen just to the air. But overall, I would say that that's pretty good for the creatures living in the creek. So my question to you is, based on the creatures that we found, how many, but also what kinds, and then based on these water quality tests, so the dissolved oxygen as well as phosphate, and then also thinking about the turbidity tube, which remember was at 65 centimeters and had excellent transparency. Take all of those things together and make a grade for the creek. Would you say it is A, super duper healthy, or F, totally devoid of life, or somewhere in between that scale. And then also say why you would give it that grade. Thanks everybody for watching the video.